Hello, ladies and gentlemen. So today we are learning how to represent and solve addition and subtraction of fractions. Today with a focus on subtraction of fractions. So these success criteria are really important, and I think we overlooked the first two for the last couple days. We know we can do it when we can use objects and pictures to represent a sum of two fractions, so adding two fractions, and use objects and pictures to represent the difference of two fractions when we subtract them. So the reason why I think we overlook this is when we are solving these, we should be using pictures. We should be using our fraction tile resource, or actually drawing it out on paper to find our answer. So today we are going to practice using those objects and pictures to solve our addition and subtraction problems. And when we're done, we'll be able to say, hey, when the fractions, for instance, 6/8 and 4/8 are separated, there will be how many eighths left? Well, if we look, right, so 6/8 minus 4/8 means that we are going to start off with 1, 2, 3, 4, 5, 6/8. And I'm going to take away 4 of them to see how many are left. Now, with these fraction tiles, it's nice to be able to just move them out of the way, but something that you may see on paper or modeled on tests is when we cross them out, right? We're crossing these out, we're getting rid of them. Now if you look, right, just with addition, I'm not changing my denominator. I'm not changing the size of these pieces. They're still eighths, right? Still 8 pieces make a whole. What I am changing is how many pieces I have. So I started off with 6 pieces. I'm taking away 4, which leaves me with 1, 2. Now another way you may see this is as a number line, where you start off with 6/8. It's asking you to move down 1, 2, 3, 4, which does bring you to the 2/8 part of our number line. So here, let's see if you can do it. If you have 4/5 and you're subtracting 3/5, what would be left? So when you have 4/5 and you separate 3/5, what would remain? So hopefully you looked at your work or actually drew it down on paper. But if you cross out 3 of these, well, you are left with 1/5. Okay, we're going to make this a little bit more challenging now. We're going to bring in mixed numbers. Good news is, it's exactly the same. So just like we saw yesterday with adding mixed numbers, the way we do this is we start off with the lowest number, with the lowest place value. So, just like with decimals or whole numbers, we start off with the lowest amount. So we have 2/4, right? 1, 2. Or taking away 1/4. So let's do that. Just going to take away one of these. And then we move on to the next place value, the whole numbers. So we have 4. We're taking away 1. Right? So I'm taking away 1 whole. And I know this is a whole because with fourths, 1, 2, 3, 4 of them, 4 of these fourths make a whole number. Which means all I have to do is count that I have 1, 2, 3 wholes and 1/4. And if I look, that makes sense, right? 2 fourths minus 1/4. 2 minus 1 equals 1. 4 minus 1 equals 3. With that being said, I know these look bigger, but let's see what we can do. If I have 4 and 6/8, right? 1, 2, 3, 4 whole numbers, and 1, 2, 3, 4, 5, 6/8. And I subtract 2 and 2/8, what would be my answer? Well, if I take away 2/8 first, and then 2 whole numbers, what I'm left with is 6/8 minus 2/8 is 4/8. Right? 1, 2, 3, 4. And then 4. 1, 2, 3, 4 minus 2 equals 2. So my answer is 2 and 4/8. Okay. But Mr. O'Connor, what about if you are subtracting a fraction that's greater than what you have? Guess what? We have practiced this. All we have to do is regroup. So here, let me show you. If we have 3 and 2/4, right? 1, 2, 3 whole numbers and 2/4, and we want to subtract 1 whole and 3/4. Well, we can first think about it as take away 1, 2, 3/4, right? And if you look here, hey, we had to move up to the whole number here. So to give you an idea, we took 3 and 2/4, and we regrouped. I took one of the whole numbers, so I crossed it out, became a 2, and I took my whole number and I made it part of my fraction. It became 1, 2, 3, 4, 5, 6/4. Now, how did we get 6? Well, if 4 makes a whole, right, just like 10 pieces makes a place value, 2 plus 4 equals 6. And, let's see. Subtracting 1 and 3/4. Well, 6/4 minus 3/4 equals 3. Oops. Running out of space. So I'll put my answer up here. 3/4. But I'm not done. I have to subtract the whole number. So 3 minus 1 equals, let's see, I have one whole number left, and 1, 2, 3/4. So while you can think about our whole number being regrouped using the pictures, we can also just solve it by making sure we cross out the 3/4 first, and then crossing out our whole numbers. So here, let's see if you can do it. Using the cross-out method, if we had 3 and 1/3, oops, here we go, 3 and 1/3, and we subtract 2 and 2/3, what would be left over? Well, let's see. We're going to subtract 1, 2/3, and as for whole numbers, subtracting 1, 2 whole numbers, well, that's 2/3. Now, if you wanted to do it with the regrouping, well, let's see. 3 and 1/3. If I take away one of these, it becomes 2. And I'm adding on a whole number. So 1 plus 3 equals 4, minus 2 and 2/3. 4 minus 2 equals 2/3. And then 2 minus 2 equals 0, which is why I have no whole numbers here. So this strategy is higher level. Right now, as long as we're able to cross out, that is enough to solve our problem. Right, thank you. Let's get to it.